Hello, today we will all be talking about the chemical properties and history of sarin gas. Here's a table of contents. As you can see, there are 6 parts, but first we'll be starting with what exactly is sarin gas. It is an organophosphorus ester that acts as an inhibitor of acetylcholine esterase, a vital enzyme for the nervous system. It is a neurotoxin which kills very easily, and although it is meant as a chemical warfare agent, it has been used plenty of times for terrorism. As for some chemical information about sarin, it actually tends to be a liquid at room temperature, but it's volatile to a very harmful extent. So don't try putting your nose close to a puddle of sarin. Very bad idea. When the phosphorus is attacked by a nucleophile, preferably by a nucleophile within an enzyme, fluoride acts as a very good leaving group. As a result, the reaction doesn't really have a strong reverse reaction, and it retains a strong bond with a nucleophile. It tends to be odorless and colorless, so it is very easy to huff a lot and yet not detect anything. Very easy way to die, and it weighs 140.09 grams per mole.
History of sarin gas. The sarin gas, the name is come from the acronym of 4 scientists' names who created it on October 1938. It is accidentally discovered by Gerhard Schrader and his team in Germany IG Farben conglomerate, while they are trying to develop a pesticide that targeted an insect's nervous system. When attempting to come into contact with the synthesis unknown liquid, Schrader and his colleagues were so incapacitated that they were unable to work for close to a month. And later, the unknown liquid is known as what we call sarin. Schrader's team was later commanded by the Nazi government to weaponize the sarin as soon as possible and abandon the pesticide research direction. It was mass-produced by Nazi army as a weapon for World War II, but Adolf Hitler decided not to use them against the Allied forces for unknown reasons. It seems like he very hated the sarin gas. And in 1993, at the United Nations Chemical Weapons Conventions, 192 member nations signed to ban sarin with other chemical weapons.
Mechanism of sarin gas. In order to understand the way sarin works, we begin by taking a brief look at how our muscles work. When our muscles are flexed, acetylcholine, a neurotransmitter, is released. Acetylcholinesterase, its corresponding enzyme, is then in charge of breaking down acetylcholine, which disrupts the chemical signals and relaxes the muscles once again. As shown on this image, a healthy system requires the release of neurotransmitters that can bind and send pulse to the muscle before being broken down completely. In other words, to form homeostasis. So then, how does sarin work? As mentioned before, due to fluoride being a good leaving group, sarin can attack the serine residue in the acetylcholinesterase and are irreversibly attached to the active site. This prevents the breakdown of acetylcholine and the relaxation of muscles. In the image, we can see sarin in red blocking our green enzyme from removing acetylcholine. Every muscle in the body, from eyes to fingertips to internal organs, will then begin to cramp and tighten. Eventually, the overstimulation ends with the cramping of the diaphragm, which shuts down the respiratory system.
Symptoms and remedies. For symptoms, on a different level exposure to the sarin gas, the symptoms are different. For moderate symptoms, it can be drowsiness, headache, watery eyes, eye pain, blurry vision, small or pinpoint pupils, cough, drooling, runny nose, rapid breathing, or chest tightness. For lethal symptoms, it can be convulsions, loss of consciousness, paralysis, or even asphyxiation. When you are unlucky to encounter with the sarin gas, it is very important to follow the following steps to minimize the harm. First, remove clothing quickly. Second, pack contaminated clothes in sealed bags to prevent further exposure. Third, flush the eyes for 10 to 15 minutes if eyes are burnt or vision is blurred. Fourth, wash body with soap and water for a long time. Fifth, which is the most important, go to the hospital as soon as possible.
Infamous uses of sarin gas. Sarin gas is one of many chemicals known to be used for biowarfare and bioterrorism. In 1995, Aum Shinrikyo, a well-established cult in Japan, placed 11 suitcases across a subway in Tokyo. At predetermined stops, the member was used the sharp tip of the umbrellas they carried to rupture the packages of sarin gas inside the suitcases before getting them away. This terrorist attack ended in the death of 13 people, with 6,000 being severely injured and 1,000 of those with severe damage in the eyes. Sarin gas was also used in 1980 during the Iran-Iraq War, where Iraq launched over 30 gas attacks totaling the death of 20,000, with many more injured. Despite the US's disapproval for biowarfare, they ended up applauding the use of this chemical to end the war. Recently, however, that view has changed once again. Syria has been under investigation for the use of biochemical weapons such as sarin gas and mustard gas. Though it has been proven that both the Syrian government and rebels are in fact using them, we do not have a clear timeline nor death count. It is fair to say, however, that it is still being used up until today. It is for these reasons that we would like to end our presentation by reminding the class to promote peace and love. Thank you.